my name is Valerie, VILYN ANAK RIJET, and my matrix number is CE190229.
Assalamualaikum and hi doctor, my name is SYAFIQAH binti ZAILANI and my matric number is TE190084.
Assalamualaikum doctor, my name is Salimah binti NASIR, my matric number CE190189.
Hi and Assalamualaikum, my name is NORASHIKIN binti NASARUDDin, my matrix number is DE190039.
In this report, we are going to discuss our findings based on the report question, which wants us to understand more on the characteristics of induction motor. An induction motor is the most commonly used electric motor in the industry, also known as asynchronous motor, because it always operates at a speed less than the synchronous speed. So what is the synchronous speed? Well, a synchronous speed is determined by the speed of a rotation of the magnetic field in a rotating machine. So why does induction motor always operates at a speed lower than the synchronous speed? This is because when the rotor in the machine rotates, it will try to achieve the same speed as the rotating magnetic field. Once the speed of the rotor and the speed of the magnetic field is equal, there will be no relative speed between the rotor and magnetic field, hence there will be no current induced in the rotor conductor. In that condition, there will be no mechanical force that acts on the rotor conductor. This causes the rotor to decelerate. As it decelerates, the relative speed between the rotor and magnetic field is re-established. So, there will be current in the rotor conductors, which cause mechanical force to act again on them. As a result, the rotor will accelerate to reach the speed of the rotating magnetic field. Thus, because of that, the rotor speed will never reach the speed of the rotating magnetic field. So let's proceed to the next slide.
I will present about methodology. The final project output will include a mention of every technique used and every component involved, as well as explanation from the chapter outline. This chapter then goes into the selected mode of analysis as well as the data collection strategy in depth. Apart from that, Microsoft Excel was given as the instrument, along with the data collecting and analysis processes. Finally, using the tabulation process, the theoretical component of this chapter concludes with a torque speed characteristic curve graph created in Microsoft Excel. Then, this is our flowchart progression. For the first, we will select the value for the parameter, and then we will calculate data for the chosen operating state that equals to 0.05. We also will plot the torque versus speed, and then we will use the Thevenin equivalent for the circuit analysis. We also calculate the data for the power converted, and then we plot the power versus speed characteristic, and then we will filter the torque versus speed and power versus speed graph from the tabulated data. Lastly, we will identify the speed of pull-out torque in torque versus speed graph without calculation. That is the end. Lastly, Microsoft Excel simulation explanation. The specification for a 50 Hz 3-phase induction motor, often known as a one-rotor motor, were chosen for the project work. For induction motor, the matching circuit are chosen with S equal to 0.05 for the operating slip, which is required to compute torque, power and efficiency. Thevenin circuit analysis is used for calculation of variate slip from 1.00 to 0.01, interval of 0.01. As stated in the theory, the Thevenin circuit analysis is utilized the calculation on variate slip from 1.00 to 0.01, interval of 0.01. After that, the data will organize. Based on the data supply, the torque versus speed characteristic graph is displayed from estimated value and tabulated data for each induced torque and rotor speed. Next, with the curve forming towards the torque and induction motor speed, the torque speed characteristic graph is then plotted. Lastly, in the power versus speed characteristic graph, the value of maximum output power speed is calculated. That's all for me. Thank you.
Result: the induction motor was an AC machine that can work in single phase or three-phase system. is also with two types of winding, such as a transformer, which is the primary and secondary. After that, in induction motor, the primary winding is referred as a stator winding, while the secondary winding was referred as rotor winding. There are two types of induction motor, is rotor and the sequel cage rotor. In our project, we were instructed and guided to use the wander rotor, or known as a slip ring motor, where the rotor winding it was connected with the slip ring. By adjusting the resistance, it allowed we to use the motor speed and torque with change the power output of the motor. Next, the synchronous speed. For the synchronous speed that we have gained, which is from this value, and the formula are given, we are use this formula. The NS is representing as the synchronous speed, the F was representing as her, and P is represent as the pole of motor. The speed will be recognized and RPM, which is revolution per minute. The rotor also cannot achieve the synchronous speed unless the EMF is being induced to the rotor, which is allow it run slower and achieve the synchronous speed. The slip represent as a connectivity between the rotor speed and slip rings. The slip ring will be staged in percentage of the synchronous speed. Parameter and variable. This is parameter that we choose. For the losses of IM, also we choose the value. This is the value, as you can see, this is the value that we choose. Slip is an interaction of the speed difference between the magnetic field speed, which is appear as NS synchronous speed, and NF, which is rotor speed. In operation of induction motor, slip tend to occur when the rotor speed is lagging the magnetic field speed. NF is greater than NS. A rotor current and rotor voltage, which is lag power, flow in the rotor winding of the induction machine. This is the formula that what I have been saying. And next, the equivalent circuit. The equivalent circuit of the induction motor concept was particularly same as the transformer concept, which is both of the works with primary and secondary winding, but it has different to the unit of induction motor, means to the secondary winding of the induction motor, the whole rotor is not stationary, such as the transformer secondary winding. The induction motor is also have 3 loops of winding is starter, which is based on the AC 3-phase system, while the rotor winding are based on the pole at the start. The connection of the equivalent from induction motor is certain phase are shown below. This is the equivalent circuit, and also this is what are the equivalent circuit are used. And after that, for the power flow and losses of an induction motor, power flow and losses, this is the figure that it can be related based on the formula given. We have obtained the converted power, which is P convert value from slip, which is 0.9 to 0. This was induction motor speed characteristic curve that we have obtained of the parameter. The maximum output is 7,672.11 watt, and it happened at speed 880 R per minute in this graph, which is for the induced torque and induction motor. The induced torque in an induction motor must be this figure. And to find the rotor current I2, the previous equivalent is replaced which is the Thevenin circuit. This one. After that, based on the formula given, we obtain the top value for slip from 0.99 to 0. This is the induction motor torque speed characteristic curve that we have also obtained for the parameter. The pull out torque of the motor is 413.94, and it happened at 850 R per minute. As you can see, this is the graph, and the 400, which is this y-axis, and 850 is in x-axis.
I will present the conclusion for Project 1. As conclusion, we are able to demonstrate the induction motor characteristic through the theoretical and simulation. The result that the operational performance of an induction motor can be studied using simulated result from Microsoft Excel. We also be able to understand the torque speed and power speed characteristic of induction motor that are to predict the behavior of the electric motor during its operation with load changes. The induction motor torque speed characteristics supply information on the relation of induced mechanical torque on mechanical speed. Sometimes, this characteristic is called torque slip characteristic, where slip is defined as speed relative to synchronous speed represented as a fraction of synchronous speed. Torque speed characteristic is the curve plot between the torque and speed of the induction motor. When load is added, the slip is increased, resulting in a decrease in speed. Increase the amount of direct current applied to the motor to compensate for this. This shows that the greater the load changes, the greater the slip value at with maximum torque occur. As the rotor resistance increases, the pull-out speed of the motor decreases. In this condition, the maximum torque remains constant.